It is an intuitive habit to assume that time passes at the same rate no matter how quickly you're traveling. But years ago, scientists Albert Michelson and Edward Morley conducted an experiment that threw this assumption into question. According to Marmot 2018, the goal of their experiment was to search for an ether, something that physicists believed had to exist for waves of light to travel through space. Waves we knew more about, like waves in a puddle, needed a medium to disturb in order to exist. Their medium was water. The medium for sound waves is air. So how could light possibly travel in empty space? The idea of the experiment was based on the knowledge that if the Earth is moving relative to the ether, a light wave traveling on Earth could be compared to a boat traveling through water. If the water is moving, the velocity of the boat headed along an axis should differ somehow from the velocity of the boat headed along a perpendicular axis. This idea was the same for light. If a light wave was headed one direction relative to the ether, it will have a different velocity than if it were headed perpendicularly. According to Moda 2007, the idea of the experiment was to send a light beam towards a semi-transparent mirror that was angled so that it would split the light beam into two beams that were perpendicular. Since the light source was the same, which means fire time was exactly the same for the two sub-beams, then the two sub-beams would arrive back at exactly the same time if there were no ether to distort this experiment. Michelson and Morley tested if the two beams had traveled at the same velocity by checking if the light waves were caught at different points in their cycles once they came back. They didn't. According to Fowler, no date, there had to be something waving if it wasn't a medium that the wave was traveling through. This is why the Michelson-Morley experiment is evidence that light is not only a wave, but also possibly a particle, a photon. But back to the experiment. According to Marmot 2018, the conclusion of the experiment was bizarre, so they altered distances during the experiment. They learned that no matter the frame of reference, the measured speed of light was always exactly the same. According to Sato 2006, not only did this experiment conclude that the ether did not exist, it also concluded that the speed of light had to be absolute. If light traveled the same no matter what frame of reference, there has to be something else going on. Think about it. For all normal objects, their velocities depend on their frame of reference. A ball sitting on a moving train has a different velocity relative to the ground than its own velocity relative to a car traveling beside the train. But if the ball on the train was replaced by a photon of light, both the car and the ground would observe that the photon is traveling at the same velocity. We could use a light clock to illustrate this phenomenon on more than one dimension. According to Zanella 2011, a light clock is just two mirrors facing each other with a photon bouncing back and forth between them. If we sit still with our own light clock and measure the velocity of the photon relative to ourselves, we will get the speed of light, a constant. If my friend is running on a horizontal plane in front of me, the photon in her light clock will be making a zigzag pattern relative to me, and if I measure the speed of the photon along its zigzag pattern, I will get the speed of light, a constant. If my running friend measures the speed of the photon of light in her light clock, which is stationary relative to her, she will get the speed of light, a constant. And there is no zigzag pattern according to her. The photon is only moving along one dimension. This shows us that the light clock illustrates the speed of light remaining constant no matter the frame of reference. Something has to be weird, and what it is that my friend's axis of space and time they're different relative to mine. Here's what her measurements look like compared to mine, and here's mine relative to hers. Look at where my time falls relative to hers, and look at where her time falls relative to mine. Time is actually being squished. Whose time is squished? It all really just depends who you ask. According to Susskind in 2012, this is the entire idea of Einstein's theory of special relativity. It's that time becomes slower the faster someone travels. Einstein carried through with his ideas and later made them apply to gravity and space. He theorized that space and time were just different ways to describe the same fabric that he called space-time. Space-time was a physical object. No, not matter, but yes, a physical object that could be impressed and compressed and stretched and manipulated, and after all, our concept of the universe was even more interesting than we thought it was. Today, concepts about special relativity and time dilation are being incorporated in how we develop our technology. For example, according to Clark 2014, man-made satellites are designed with the concept of time dilation in mind. As a more abstract viewpoint, time dilation is even more relevant in tomorrow's world. Even though there is not a long list of specific societal developments that stem from an understanding of Einstein's relativity, this is how all great innovations and discoveries are founded. Pure curiosity over a perhaps seemingly unprofitable but wondrous subject.